Good afternoon to all of you. I'm Guy Brasseur. I'm the moderator of this session today in the afternoon. I'm the chair of the steering committee of the World Climate Research Program, WCRP, which is hosted by the World Meteorological Organization. I would like to welcome all of you, just to say that we're very happy to see you here as an audience to discuss the theme of this meeting, of this symposium, or kind of small symposium, which is importance of the science in supporting adaptation and mitigation under the Paris Agreement. And to discuss this issue before you will have an opportunity to make your points and to intervene, especially at the end, during the discussion time at the end of this session, we have invited a number of experts. First of all, on my left here is Professor Taalas, who is the Secretary General of the World Meteorological Organization, in other words, the boss of the organization. He's also an old long-term friend of mine, and he will talk about the state of the climate and tell you how WMO sees the evolution of the research and the whole state, basically, of affairs related to climate change. Then, next to him is Professor Stephen Briggs. Professor Briggs is the chair of the Global Climate Observing System, GCOS, which is another program in the WMO. And he would like to tell you his views on how to strengthen systematic observations and basically indicators for climate. Then we'll talk a bit about another activity that you know, and all of you know very well, and that's the Intergovernmental Panel on Climate Change, IPCC. IPCC has played, of course, a very important role in preparation to many of the negotiations. And we have here Dr. Jan Fuglestvedt from a group called CICERO, Center for International Climate and Environmental Research, which is located in Oslo, in Norway. And then finally, and I think I'm really pleased we're doing that, we're going to look at one of the application, if you want, or impacts of climate change, and that has to do with the food system and hunger. Basically, how can we apply the science, and climate science in particular, to combat hunger? And Dr. Tanya from the World Food Program will be telling about it. Now, you might see at the end of the table over there, Dr. Elena Monachenko, I have always hard time to, okay, thank you, who is the Deputy Secretary General of the World Meteorological Organization. She has not prepared a talk specifically, but she will be at the table to participate in the discussion, especially because Taalas has indicated to me that in a few minutes he has to join another meeting next door, and so he will have to leave us, but he will be very well replaced by Elena in a few minutes. All right, so let's start then the presentation. They will last roughly 10 minutes, and we're going to ask Taalas to give us a bit of his view on the state of the climate. So, Petteri, your turn.
Thank you, Guy, and welcome also on my behalf. I used to be a scientist for the 15 first years of my career, and thereafter I became a bureaucrat. And now I've been leading WMO for the past 2 years, and we noticed at the last COP that since IPCC reports appear every 6 to 7 years, there's a need for complementary material to motivate the negotiators to proceed with the climate mitigation efforts. And that's why we decided to publish an annual State of Climate report, and it's a joint report by not only WMO, but we have several UN. Can I have the next one, please? Okay, good. Yeah. So we have several UN agencies who have been contributing to our report, and we have also several world-leading climate experts who have been contributing to this report. And there will be a press release in an hour from now, so don't tell the press yet what I'm telling you now. So this is what we have observed in temperature, and we have exceeded this 1.1 degree level already last year, and since this El Nino is over, we are returning back to more normal numbers. And in this report now we are having two new data sets. We have one from Japan and one from ECMWF, and besides the previous two US and one UK Met Office records, and they are more or less showing the same story here. And the last 3 years they have been warmest on the record. And if you look at the situation so far this year, what kind of anomalies we have been observing, you can see that high northern latitudes we have seen again the biggest deviations. That has been the story for fairly long time. In the northern part of North Atlantic, there seems to be an anomaly which we have been observing for fairly long time, and that's likely to be related to the melting of the Greenland ice and slowdown of this ocean current from Caribbean towards Western Europe. And also over Antarctica we have seen anomalies, but globally the whole world seems to be warmer than it used to be before. And coming back to this El Nino issue, so last 2 years, 2015 and 16, the temperatures were boosted by a fairly strong El Nino, and it's fair to compare 2014, which is the last gray bar here, and this year's temperature 2017. And you can see that by comparing 2014 and 17, this positive trend in temperature clearly continues, but this El Nino impact is more or less has vanished. And if we smoothen this time series by having 5-year averages, you can see that this trend is continuing. And if you compare last 5 years with the previous 5-year periods, you can see that this warming trend clearly continues. We have broken this 1 degree level there, which was not the case some years ago. And here is a comparison of 2 5-year periods, and you can see what has happened over the continents. In general, we can see higher numbers, and also at the high latitudes you can see higher numbers, and also in most parts of the ocean areas, the deviations for the past 5 years they are larger than for this previous period. And global sea level rise continues. This is from the satellite era of measurements, and if we start these measurements from 1870s, we end up having 26 centimeters of sea level rise so far. And here is a graph showing which are the factors behind this sea level rise during the past 22 years, and you can see that this thermal expansion is the largest factor, but we have fairly strong contribution from the glaciers which are melting, and Greenland is third one, and thereafter we have southern hemisphere, Antarctica, and then land waters is the last factor here. And if we compare what was the case from 93 to 2004, and for the past 10 years evolution, one can show that there has been a boost in the sea level rise, and especially the component of Greenland has been rising fairly dramatically, and that's also the case in thermal expansion and glaciers, but especially this Greenland component is quite obvious here. And since we have produced more carbon to the atmosphere, we have started seeing acidification of the ocean seawater, and that's the case especially at the high latitudes. This temperature of the seawater is a factor driving this as well, and this is a long-term threat for the ocean ecosystems. And we have broken also the records of methane, N2O, and carbon dioxide concentrations. Here we have carbon dioxide, and we exceeded 400 ppm already a year ago, and last year we reached 403 ppm, and the annual growth rate last year was 3.3, which is the highest growth rate that we have ever measured, and this concentration is highest in 3 million years at the moment. Sea ice in the Arctic, we are closer to the normals as compared to the last 2 years, but still we are well below the normal, and in southern hemisphere we have just broken record when it comes to the annual maximum of sea ice coverage, which is unusual. This Antarctic feature has been fairly unusual for the past 3 years. And we have seen very active hurricane season in the Caribbean, and we have broken the record in the amount of hurricanes in such a short period, and also this hurricane Irma was persisting 37 hours as a category 5 hurricane, which is also the world record so far. And in Houston, Texas, we were having severe flooding, and again this amount of rainfall was very unusual. Global precipitation has been, we have seen anomalies in many places of the world, and in many cases it has led to forest fires like in Canada and in Mediterranean region, and we have seen flooding in Himalayas and also in southern America. And in Himalayas there have been millions of people which have been affected by the severe floods recently. And these heat and drought events in Portugal, USA, Canada, Argentina and Chile, they have led to forest fires, and in Argentina we have broken all-time high 43.5 degrees at the 43 south latitude. And this is an estimate of World Health Organization, how many people are exposed to heat waves, and there's clearly an upward trend here, and in 2015 there was about 175 million people which were exposed to heat waves. And drought is a problem in many fragile countries like Somalia, South Sudan and Yemen, and this is an example from East Africa, where 3 countries, Somalia, Ethiopia and Kenya, have been suffering because of drought. And this is my last slide. This is from IMF. They have estimated that whereas the high northern latitude countries may benefit from this climate change, large part of the world is suffering, and especially southern hemispheric countries are really suffering because of this 1 degree warming that we have observed so far. So that's the report that is going to be published in an hour from now. Thank you.
Okay, thank you very much. And we're going to leave time for discussion afterwards. But if anybody before Petari leaves has a very specific question, not a big discourse, but a technical question, we can take it right now. We'll leave the discussion for later on. Anybody wants to ask anything? If not, we're going to let you go to another session. Thank you very much, Petari, for your presentation, which I think summarized very well the problem that we are facing. Well, observation is, of course, central to understanding the climate system and following its evolution. And so Stephen Briggs is here. Please, why don't you give us your presentation now?
Thank you very much. I'd like to speak this afternoon briefly about the importance of observations for science and for supporting the understanding of climate and climate adaptation and mitigation as well. And that lot falls to the Global Climate Observing System, which I have the honor to be the chairman of the steering committee. And this is the body which was set up some 25 years ago to define the requirements for and to advocate for the production of the observations which are required in order to understand climate and to deal with its consequences. And the core of the requirements come out of the Paris Agreement. If we look at Article 7C, then that specifically requires us to improve knowledge of the climate system, the scientific knowledge, including research systems and systematic observations. And that's really the core remit which GCOS has to support. But if we look across the whole of the Paris Agreement, we see in many of the different articles, different aspects which also require improved observations. Clearly things like the global stocktake and aspects such as that, but also in mitigation, in loss and damage. These are important areas, and I'm sure you'll hear over the next 2 weeks a great deal of discussion on adaptation, loss and damage, and other aspects of the Paris Agreement and its outcomes over and above the headlines of 2 degrees, 1.5 degrees, and CO2 rise. So there's a requirement for observations throughout the whole gamut of different activities related to climate and to the Paris Agreement. And in order to implement our work, we have delivered to the Paris COP in 2015 a status report on the current status of climate observations globally. And following the publication of that report, we then worked afterwards for an implementation plan, which was delivered 1 year ago to the Marrakesh COP, to explain exactly how we plan to deliver those observations in future. And that discusses not only the core observations, the so-called climate variables that I'll come to in a moment, but also aspects which are required to do with delivering services and mitigation, adaptation beyond. So I mentioned the essential climate variables. I have to put up this slide because this is essentially the core business of GCOS. It is to specify the requirements for and deliver some 50 or so different variables which support the understanding, the modeling and prediction of climate. And you see them there, classified according to atmosphere, ocean, terrestrial observations, earth, air, fire, water. We're still Aristotelian in that, but also in terms of the way that they interact with each other. And that's important because science, of course, is not divided into boxes which we can conveniently put and discuss in isolation. So we have terrestrial observations, ocean observations, atmospheric observations, which are needed to understand the water cycle, the energy cycle, and the carbon cycle, and the way that they all interact with each other to give us a profound understanding of global climate in its entirety. And this is where the observations support the research of WCRP and other programs which give us the basic understanding which is needed in order to understand what to do about the aspects of change which we are suffering. Of course, it's impossible to discuss climate on its own, and today we talk a great deal about the Sustainable Development Goals, the 17 goals which have been identified by the UN for Sustainable Development by 2030. And one of those, number 13, is climate. But climate is not just restricted to that single goal. If one looks across these, then probably about 2/3 of these goals are dependent on better information and better understanding of climate and better observations of climate and climate change. Things like water, agriculture, and food, and so on, are all clearly very closely related to our understanding of climate. So we are not restricted just to that one SDG, and we really support the entire range of those 17 different goals. Something new in the last version of the implementation plan for GCOS also was the identification of a number of so-called headline indicators. And Petri has already mentioned a few of these. And it's important, I think, that we have a few rather straightforward indicators like this in order to enable a better discussion about climate. The ECVs, the essential climate variables, are very important, and they're defined in the light of the scientific requirements. But at 50-something, about 54 of those we have, there are really too many of those to have an open dialogue and discussion with a wider community. And so it's easier to focus on a smaller number, and here we've selected and proposed that there should be 7, which we've identified. You've heard about surface temperature already from Petri, also about sea ice and glacier mass balance and sea level rise. It's interesting to think about energy imbalance. We talk a lot about surface temperature, and it's important because it's where we live, but it's also what governs the processes at the Earth's surface. But over 90% of the energy which is accumulated as a result of our increasing effectiveness of trapping heat in the Earth's system goes into the ocean. Enormous amounts of it. I don't think we understand just how much it is. It's about 5 zettajoules a year. Now, a zettajoule doesn't mean very much to me, and probably not to you either. But if we think that the entirety of mankind's energy generation, by all means, fossil fuel, nuclear, renewable, transport, and everything else, is about half a zettajoule a year. So the Earth is warming up at 10 times the rate that mankind is generating energy. And that gives us an idea of the profound size of climate change. And most of that is going into the ocean. Petri mentioned sea level rise. I'm not going to go through all of these. I'm just going to look at this one. And this is a different way of looking at the point he made, which is to look at not only are we able to measure quite precisely now the extent of sea level rise, but we're beginning to understand what the causes of it are as well. So the black line you see here is the altimetric measurements of sea level, simply the external measurement of where the surface of the ocean is. But if we look at the blue and red, the yellow and the green and blue, green is the thermal expansion of the ocean. Blue is tracking the additional water mass which is entered into the ocean as a result of the melting of various forms of ice. And when we add these together, we get the red curve. And ideally, the red curve and the black curve should be coincident. And indeed, fortunately, they are pretty well. So we not only are able to observe sea level, but we have quite a good understanding of what's causing it. But it's not isotropic. It's not the same everywhere all around the world. If we look at North Atlantic, for example, then on the west coast of the United States and Canada, sea level is actually dropping in relation to land. But in the areas which unfortunately are most susceptible in many cases in the Southwest Pacific, then we see the greatest, most rapid rise in sea level. And that can be something like 3 times or 4 times the average 3 millimeters a year or so. It's about 4 times that in the Southwest Pacific. So unfortunately, it's probably an area which is where they're most susceptible also to sea level rise. So we're able to get information not just about a single figure for the world, but also some idea of what the distribution of sea level rise is, which is very important when we come to think about adaptation and looking at the consequences of climate change. And these are all from more examples of the observations which are needed. This is some work that was done recently, a workshop that was held just a couple of weeks ago, jointly between the WMO Integrated Global Observing System, WIGOS, and GCOS, to look at the requirements for upper air observations in the South Pacific. Unfortunately, our observations of climate generally across the world are not evenly distributed. They're not evenly spaced. And there are many areas of the world where we have very few observations, and the South Pacific is one of those. So this was an important initiative to try and improve our understanding of parameters in the upper atmosphere, which are not only important clearly for that local region, but for us all around the world. So we're working with colleagues in WMO to try and enhance and improve our observations of the upper atmosphere. Satellites are giving us new observations which we didn't have before. One of our new ECVs, which comes into the implementation plan last year, is lightning. We are now able to measure routinely and accurately the lightning events across the globe. And these are an important proxy for the numbers and severity of storms. And so lightning is one of our new parameters which describes the progress of climate change. And finally, another observation which is based in as are many of the observations which are required for climate are made by our weather services worldwide and meteorological agencies. Many of those have weather radars, and they are very important for weather prediction, but also with an extension of their capacity, precision, and timeliness, we are able to provide much better information about precipitation for climate aspects as well. So again, this is another example where we build on the observations being made to date, traditionally by meteorological agencies for their purposes of weather forecasting, but they are fundamentally the observations which are also needed for us to understand and to predict climate. So we have a wide range of different types of observations from different types of sources, and GCOS is the body which tries to bring those together into a coherent whole with our partners in WMO and elsewhere to provide the basis of the information that's needed for our scientific understanding and management of climate change. Thank you very much.
Thank you, Stephen, for this very nice presentation and also for the very nice picture on lightning. I think it's a fabulous picture. Okay, now, as you know, periodically the Intergovernmental Panel for Climate Change is releasing kind of an assessment report, in fact 3 of them. We have here, very happy to have the Vice Chair of IPCC Working Group 1, who will tell us a bit about the preparation of the next report, which has just started, and which should give us an update of what we know about the climate system. So Jan Fuglestvedt is here, and you will give us this presentation.
Thank you, Guy. Yes, I will talk about what's coming from IPCC over the next 5 years. And if we look back since 1990, IPCC has produced a large number of comprehensive reports. And now we are in the 6th cycle, and this is a very busy and ambitious cycle. At the start of this cycle, we received many proposals for special reports on many important and topical issues. And among these, we also got a very special invitation from Paris meeting 2 years ago. And when we had the first plenary meeting of the 6th cycle in Nairobi in April 2016, it was decided to respond positively to the invitation from the Paris meeting and produce a report on the impacts of 1.5 and the emissions consistent with 1.5 in the context of sustainable development. It was also decided to produce a special report on climate change and the oceans and the cryosphere. And the third special report is on climate change, desertification, land degradation, sustainable land management, food security, and greenhouse gas fluxes in terrestrial ecosystems. So 3 special reports, that's quite unusual in a cycle, and that comes in addition to the traditional main report with contributions from all the 3 working groups, leading up to a synthesis report. In addition to this main report, there will also be a methodology report about greenhouse gas inventories. And one of the proposals for a special report was on cities. And instead it was decided to pay more attention to cities and climate change and organize a conference on this topic and have a special report in the 7th cycle. So as you can see, it's a very ambitious and busy program we have ahead of us. So if we look closer at the 1.5 report, here you can see the structure, the outline of the report. It starts with the framing chapter, which discuss key concepts, the storyline of the report, uncertainty language, etc. It sets the scene of that special report. Chapter 2 of that special report is about the mitigation pathways and missions that will lead us to 1.5. What are the allowable emission pathways consistent with 1.5 in the context of sustainable development? And then chapter 3, the largest chapter on impacts on natural and human systems. Chapter 4 is about how to make things happen in the real world, strengthening the global response and implementation. 50 pages. And then the final chapter about sustainable development, poverty eradication, and reducing inequalities. And during this summer, we produced the first order draft that was sent out for expert review, and we received almost 13,000 comments to that draft, which is, in my view, an indicator of success, or at least people are interested in this report. And they come from almost 500 experts from 61 countries. And you can see Europe is the main contributor to the review comments, but also US and Asia gave important contributions here. And it was the chapter on impacts on natural and human systems that received most comments, almost 4,000 comments. So right now the authors are responding to those comments and revising the text. Also the framing chapter and the implementation chapter received a lot of interest from the reviewers. So early next year, we will have a second order draft that will be sent out for government and expert review. And after that, we will revise and make the final draft. I will come back to the timeline later. And then the second special report on land, climate change and land. Again, we start with a framing and context chapter, setting the scene, discussing key concepts, explaining the storyline of the report. Then chapter 2 reflects new science since AR5 about land-climate interactions. Chapter 3 about desertification. Chapter 4, land degradation. A separate chapter on food security. And then a chapter on interlinkages, synergies and trade-offs and integrated response options. And then the final chapter on risk management and decision-making. This special report had its first lead author meeting in Oslo in October, and it will later produce a first order draft that will be sent out for government or for expert review. That was the second special report. And then the special report on ocean and cryosphere. Again, we start with the framing chapter, and then there's a separate chapter on high mountain areas, and a chapter on polar regions, then sea level rise and implications for coasts and communities. Chapter 5, changing ocean, marine ecosystems and dependent communities. And the final chapter is on extremes, abrupt changes and managing risks. And this report had its first lead author meeting in Fiji in October. Then you've seen this figure before about the long way from a decision to a publication of a report from IPCC. First there is a decision, and there is a scoping, and then the approval of the outline, nomination of authors. The authors meet to produce drafts that are sent out for reviews, and then in the end there will be an approval session, and finally publication. In May, we organized the scoping meeting for the main report. Working Group 1, 2, and 3 report of the 6th cycle. We had 180 experts together in Addis Ababa. They produced an outline that was presented to the plenary in September in Montreal and approved there. And if we now take a look at Working Group 1 outline, you will notice it's quite different from AR4 and AR5. We have changed the structure quite, I wouldn't say dramatically, but significantly, and we try out a new way of approaching this topic now. We start with a framing context chapter, setting the scene, and explaining how the report is organized. Then we have 2 chapters about where do we stand now. The first one is the changing state of the climate system, and the next one is about the human role in that system. That contains attribution. And then we have a block of chapters about processes controlling the responses in the future. Chapter 4 is about scenarios, near-term and long-term scenarios. And then we have process-oriented chapters about the carbon cycles. We have a new chapter about short-lived climate forces. Chapter 7 is about the energy budget, climate feedbacks, and climate sensitivity. Chapter 8, water cycle changes. Chapter 9, cryosphere and sea level change. And then we have 3 chapters which forms the bridge to Working Group 2. It starts with linking global to regional climate change. And then a chapter on weather extremes in a changing climate. And then the final chapter is called Climate Change Information for Regional Impacts for Risk Assessment. And that is really the bridge to the impact assessment in Working Group 2, and is quite novel in the way IPCC has organized the reports previously. So we can also notice that this new way of organizing the material introduces new challenges, because now we don't have chapters that are in a way boxes where topics are discussed. Topics are discussed across the chapters. For instance, extreme events will be discussed in several chapters here, so we have to find new ways of working together across the chapters. Also, radiative forcing will be assessed in several chapters. So this represents a challenge, but also an opportunity to establish new interfaces between scientists. There are also important links to the other working groups. I mentioned the bridge to working group 2. You can see, I don't see the color here. It's, the red is the link to working group 2, and the green represent the chapters that are important for working group 3. So we are very focused on establishing more integrated ways of working across the working groups, not only across the chapters, but also across the disciplines. If we look at working group 2, it's a bit more complex, this structure. We have a section I've divided here into 3 different sections. The first on the risks, adaptation and sustainability. And here you can see the different components of the climate systems are treated. Then we have the next section about the regions, Europe, Africa, etc. And then if you look to the right, you can see a new type of material, cross-chapter papers, which is a novel approach to the regional perspectives. And finally, section 3, sustainable development pathways, integrating adaptation mitigation. That's the final section. So a lot of chapters, but divided into different sections. That was working group 2. And working group 3 also has a bit more complex structure than working group 1. It starts with the synthesis chapter, or setting the scene chapter, and it ends with the synthesis. And here in the middle, you can see the core chapters about the sectors, energy, agriculture, etc. And then we have a block of chapters about scenarios in the future, the drivers of change, and also backward-looking, understanding the emission trends. And we will also have chapters about institutional challenges and policy, and also about finance and technology here. Again, a quite new structure compared to previous assessments. And it will also use the links to working group 2 and 3. So, as you can see, we have some challenging and quite novel structures of the main reports ahead of us. And we just had the call for nomination of authors, and more than 2,000 were nominated for working group 1, 2,371 authors were nominated, or persons nominated for authors. Working group 3, working group 2, more than 3,000, and working group 3, more than 2,000. And the decision on author teams will be made in end of January or beginning of February. So, yeah, I will just finalize by this timeline, because as you've seen, there are many elements in our work program. And here, the first thing to happen is next fall, the special report on 1.5. Approximately 1 year later, the land report and the ocean report will come out next fall, fall 2019. And then the first part of the main report, working group 1, and then working group 3, we changed the order here, and then working group 2, and finally the synthesis report. And everything is aligned with the Paris process, so we can provide input to the dialogue and the global stocktake. Thank you for your attention.
Thank you very much, Jan. And now we're going to move to an interesting application of climate-related questions. You know that many places in the world, climate services have been established. In fact, WMO has a global framework for climate services, and climate services support adaptation measures, but also those that relate to food insecure population. And Tanya Osejo from the World Food Programme will talk about that, please.
Thank you. Thank you so much. It's better, okay. Thank you so much. My presentation is focused mainly on how WFP as a user of information is trying a little bit to understand and apply the science that we receive from the scientific community into our operations in general terms. So first of all, what I would like to say is, like, for WFP, what is key for us is understanding a little bit the risk within the information that we have. But the changes in vulnerability and the changes in the hazards, is there any changes in the patterns that we are observing so far that we have to be aware of? And how this information will have an impact not only in food production, but also in other pillars of food security. We are talking about food access, utilization, and food stability over time. What does it mean? For food security, the different specific warming levels at 1.5 degrees, at 2 degrees, and 4 degrees. Also, the questions that we have is like, where this population will be located, the most affected one? What will be the most urgent needs that we will have in the future? So how to translate this complex scientific information into activities that trigger action, so that in the decision-making process, for instance. So these are just a few figures about what WFP has been doing and has been facing, related basically to the emergency responses and post-disaster recovery operations that we have been dealing. And this is the latest information that we have from 2015. Here you will see, for instance, that 14.5 million people has been participating in our programs related to emergency operations. But this one has implications, economic implications in the investments that we are doing around the world with our beneficiaries. Nowadays, WFP is spending around 2.3 billion annually in emergency and post responses after a shock hits a specific region, for instance. So these numbers are important to WFP, and we need information in order how to reduce the number of population affected by climate shocks, for instance, and also how to reduce, instead of investing in emergency operations or responses, how to invest much better in anticipation. In what we are saying about early warning systems and other activities that enhance the resilience capabilities of food insecure populations, communities that we are working on. So for us, the integration of improved knowledge into local, national, global systems and planning processes, and improve the capacity for vulnerable food secure countries and communities to better address the impacts of climate change to food security and nutrition is the main goal that we are trying to achieve so far. We have been working with different research centers, and this is just one example of one of the efforts that we have been doing together with a research project that is called the High-End Climate Impacts and Extreme. This is one of the results that we have been collaborating together with the UK Met Office, for instance. At global level, we are trying to identify what does it mean 1.5 degrees, 2 degrees, 4 degrees for food security. And this is just an example of the vulnerability to food insecurity, how can be affected at the different specific warming levels. So one of the key results that we have so far, for instance, that in absence of adaptation in a 2 degrees warmer world, there's an estimation of 189 million people are projected to experience levels of vulnerability that we haven't seen before. In a 4 degrees warmer world, the figure increases to 1.8 billion so far. This is the estimations that we have, and this is the most recent information that we are receiving, that we have been building together with our partners. By 2050, the largest increases in vulnerability to food insecurity are located in South Asia. But by 2080, it looks like the largest increases are going to be in Central America, Venezuela, Colombia, and South Asia. So is how to translate this information in a little bit of impacts that help us to understand the focus of our operations and understand the hazards that we have to face so far. At national level, we also are working with our research institutes or our partners in general terms in order to understand the impacts not only at local level, but also at national level, and also downscale the information to a local level if it is possible. So this is another example. This is a case of Bangladesh with the research institutes. Once again, the UK Met Office in this case is translating the information, downscaling, and trying to understand a little bit where are the hazards, where are the vulnerabilities, and then use this information for planning purposes as well. Here just a few examples how WFP is using this information so far that we have available. This kind of activities goes to understand better the impacts of climate change to food security and nutrition at national level. So we are conducting analysis in that area, but also how to use the information to inform our strategies that we are working in different countries. Some examples that I'm bringing today is about the Rural Resilience Initiative. Some of you might be familiar with the weather index insurance. This is one of the components that it has in the Rural Resilience Initiative, and also climate services that we have been working together with different partners, including WMO and FAO and others. This is a little bit the results that we have so far for the initiative that I'm referring to as the Rural Resilience Initiative, otherwise as R4. R4 is like an integrated risk management responses that includes not only the weather index insurance, but it's the weather index insurance integrated into a better management of natural resources, as well as we have a component of livelihood diversification, savings, microcredits. So the participants in these programs who are already, first of all, is target groups that are food insecure. They are participating in our programs, and we are designing weather index insurance together with different research institutes, and the farmers, our participants, can apply and be insured against a drought so far. We are also developing weather insurance for livestock as well, so these products. So to design this product, we need seasonal forecasts, and also to trigger action if there's a drought, for instance, that we had in the phenomenon, El Niño phenomenon, for instance, is like how the system in a specific country has to respond to that farmer that is insured against a drought. And we have been responding to that, and during the phenomenon in 2015 and 2016, the payouts were triggered, and then 525,000 payouts were released as a response of El Niño phenomenon. The beneficiaries were investing doing investments with these payouts in order to reduce the vulnerability that they were facing at the moment when they are dealing with the El Niño phenomenon. But the results that we have so far is not about how much money the beneficiary received, how much money the person who is participating in the program received, but also we measure the impacts in terms of food security as well. So those beneficiaries who were participating in our program, we were monitoring the food consumption score and also the coping strategy index, and we find out that people who were participating in R4, the food consumption score was twice higher than those ones who were not part of the program. And in terms of the coping strategy index, it was 3 times higher because the investments that they did, the protection that they received through the weather index insurance and the decision that they made, well-informed decisions that they made, helped them in order to reduce the vulnerability that they were facing at the moment. Other example that we have is in terms of climate services. We are right now implementing, we implement a project together with different partners on climate services in Africa. Specifically in the case of WFP, was working in Malawi and Tanzania. Right now, we are just doing the impact evaluation of the program that came to an end, but so far, we can share a little bit of the results that we have so far. In the case of Malawi, we have received information that the participants in the program have increased the crop yields. But the most important thing is like they have adopted better practices, improved practices in agriculture and livestock. And we have received information as well that these practices have helped to diversify the livelihoods, the livelihoods and also income sources at the same time. Once again, food consumption score and other food security indicators have been helping us in order to see that what will be the impacts of translating climate information into something that is useful not only in early warning systems, but also at farmer level in order to make the decisions that improve their adaptive capacity to climate shocks. Finally, just to share with you a little bit of the information that we are doing as WFP as our next steps with the approach that we are taking with climate change and impacts of food security and nutrition. We are focused right now in how to improve the quality of programs that will last in resilience. This year, WFP approved its first policy on climate change for food security and nutrition. Our country offices are designing the country strategic plans, the plans for the next 5 years. We have received so many questions for many countries, our country offices, how to integrate climate change into WFP activities. So far, we have examples such as our country offices in Sudan, for instance, Malawi, Tanzania, Colombia, they have integrated climate change into their programs for the next years. And this is a little bit of the activities, program activities that we are planning to integrate information that we have about changes in vulnerabilities, changes in the risks, changes in the patterns that we have seen, how can we integrate it into our activities in early warnings, emergency preparedness and response and so on. Finally, a few of the lessons learned of WFP, user of information that demands information to translate it into impacts, food security and nutrition. The first thing that we wanted to share with you is like impacts on climate change on food security and nutrition vary across the world. I mean, depend on the context, depend on the policy. So we have to learn very, very hard that we have to be flexible and we need to tailor the tools, the analysis, the approaches that we are doing because the contexts are a little bit different. We face data constraints. Instead, there are some countries that we don't have the data that is required not only on food security, but some data that is a socioeconomic data that we have to take into account. Assessing the contribution of different climate factors to food insecurity is very tricky because there are other factors that we have to take into consideration that may be more important or they are influencing food insecurity in a specific country. So finally, just wanted to share with you that partnerships is important. WFP is an institution, humanitarian organization, but needs information from the scientific community in order to take decisions and also inform and work together with the government, with the municipalities, with the leaders in different levels in order to understand better the impacts, but also how to address them. Key questions that we have for the future right now is how to integrate traditional knowledge and also the gender component in our operations related to climate change. If you would like to have more information, you can visit the websites, and also we have the research center that we have been working together with this Helix project about the impacts of climate change at 1.5 for 2 and 4 degrees. Thank you so much.
Thank you very much. I think I like very much the sentence you were using, saying basically we have to translate complex information into a format that trigger action. And that's probably a good way to summarize what COP23 is about. So thank you very much. It's now time for debate and discussion. But before I open the floor to your questions or your comment, I'd like to take the opportunity to thank Caroline Richter, who is here in the room and has really prepared this session today, and I think she deserves our applause also. So I think we heard quite a bit of point of view on issues that are very fundamental to the science in relation to climate change. And perhaps the question that we could ask ourselves and that the scientists are asking themselves is, what should the science do these days and how should the science evolve after, in particular, the Paris Agreement? What are the topics that deserve priority? Where should the focus be? And how can the science help implementing basically mitigation and adaptation policies? So I don't know if you have some ideas about that, but I would like to open the floor now for comments, suggestions, criticism perhaps to what we heard, and let's start the debate. So who would like to start and make some comments? Yes.
Hi everyone. Thanks a lot. I'm studying engineering in France, and that's very inspiring to see that scientists also work for climate change and not against climate change and not for climate change, as we see in our schools. I think one solution would be to study the impact of raw materials and their limits, that raw materials are limits, and to see more these things into studies. And I have a question to all of you. How do you stay optimistic facing all these figures all the time? How do you stay optimistic?
Okay, thank you. So basically two questions. One has to do with raw material and how they would impact the fate of the planet. And the other one is a more personal question. How can we be optimistic with a number of information we receive? We heard last week that climate change is occurring, that CO2 has never been as high as today, et cetera, et cetera. How can we be optimistic? Perhaps we'll take 2 or 3 questions, then we'll ask the panel to respond to those. So is anybody, wants anybody to make an additional comment at this point? I see somebody there. Maybe you give your name and your affiliation if you want to.
My name is Daryl Daniluk, and I'm here representing the World Federation of Engineering Organizations. And my colleague in the back, as a student, has raised a very good point. It's important to integrate the scientific fact that is being developed by the Framework Convention and the IPCC, and have that embedded in the education of the young engineers, the young architects, the young planners, the young agronomists, and the list goes on. And you could put an umbrella over top of them and call them practitioners. The practitioners are here as individuals, not as a recognized body. And I think WMO could go a long way to enhancing the output of their work by linking together with those practitioner groups such as WMO or WFEO and FIDIC and other groups, and have them input. The perspective that the practitioners will present to you on day-to-day activities and potential solutions will help you along, would help you a long way in your work, just for debate.
Thank you. Maybe we'll ask the panel to comment or respond to these questions. I think they were really well related. It's time now for the engineers and the practitioners and the architect and many other professional groups to jump in the hot water and become involved. How do we do that? Education, you mentioned, is very important. So any comments on that by one of you? Elena?
I will start with how being optimistic. So WMO actually have issued the first intergovernmental statement on changing climate in 1956. After 2 climate conferences, global ones, this convention was created. After 25 years of existence of convention, 23 let's say, Paris Agreement was signed. We are very, very optimistic that we are going into right direction. Secondly, we have sustainable development goals. And what Patricia Spinoza is talking in each time she speaks, she says climate change is not just for this convention, is not in Paris, is not in Bonn, it's everywhere. It talks about health and food and engineering and construction and education. This is here. So that's why we are optimistic, because we are started talking right language here. So how else we can be optimistic? This room is full of young people, just a couple of not very young, one speaker, and also Guillermo Navarro, who I see, our Director of Weather Service of Chile, but others are young people. Why did you come here to science event? You're interested. You have here essentially the whole value chain represented. You see the first and foremost global climate observing system, which Steve talked to you, it's all observations. I can talk hours about how we do observations, how complicated it is, how we standardize, how we freely exchange. This is all big enterprise. Then what we do with these observations, we put them in the models, because these models can tell you about forecasts for a month, for the season, for a year, interannual. There are many things we don't know because our forecasts are not perfect. What Tanya was telling, she needs better forecasts for her services. Then we need the science, and we have whole climate research program, which our moderator represents. There are many things we don't know. There are many things we will not know in 10 years. But the speed we are moving together is very important. So, and the last thing, we need early warning systems, and we need risk assessment, as Jan said, or also Tanya said. But most of the national development contributions of this convention are telling a story of a need to adapt in agriculture sector, and health sector, and water sector, and in disaster sector. But very few of them are actually aware what their climate risks are, and this is our job to give them this knowledge. So we're very optimistic, Mr. Moderator.
Thank you. Yes, well, maybe just to pick up that point, I'm by nature an optimist, and therefore I hope for the best. But I think there's some evidence that we can expect the best as well. If we just look at energy generation and the changes in the last 20 years, there was a period about 3 weeks ago in the UK, where I come from, where the entire use of energy in the UK for that period in the afternoon of one Saturday afternoon was less than the total amount of renewable energy being generated at the time. Now, that's something which 20 years ago would have been quite unthinkable. Yes, there are still lots of problems associated with that, and we're not at the end of the technology, but we're getting there. And I think that I'm optimistic about technology. I believe that when we look at historically the technological challenges, we discover that they've been solved in timescales which are usually a half or a tenth of the time that people thought it would take to actually resolve them. And I'm confident we will resolve the technological questions we have about energy generation, about batteries, about energy storage, and many other aspects in the next 10 or 20 years. And I suspect in 10 years' time, most of them will have been resolved. I'm optimistic about the capacity of technology to resolve that. The fecklessness of people, well, you're going to have to decide on your own about that. In terms of integrated engineering, I think it's very interesting, the question there. I was at a meeting recently with the Asian Development Bank looking at the responses of Asian cities to climate adaptation and resilience and risk. And cities are very good examples of the way that action can be taken. And I'm not sure quite why that is. I think it's possibly because they tend to be quite focused. They tend to have one problem. Different cities have different problems, but each city has generally one particular threat, which may be rising sea level, it may be increased flooding, it may be drought, it may be whatever. But it tends to be focused. The organization of the government locally tends to be quite well structured. They have budgets, and they tend to be quite, they have a very clear picture about what they need to do. And so if you look at the way that cities respond to climate threat, they tend to be much more effective than regions or countries. And I think that's because they're able to put their hands around the problem, get their arms around it, and understand what the engineering requirements are to solve that problem in their particular location. And so I think they often show very good examples of where the understanding of the predictions of what the envelope of climate is likely to deliver to us and how that affects a very specific locale is then integrated with the local engineering expertise. Thank you.
Good, thank you. We'll go for another round of comments and questions. I see there, I see there. And I see that. Let's say those 3 questions, and then we'll comment on those.
Yes, my name is Rolf Rietbroek. I'm a researcher on sea level here in the University of Bonn. I'll probably talk from a scientist perspective. You mentioned, especially concerning the essential climate variables, that establishing a systematic long-term monitoring system is important. And I was wondering if what are your ideas on how to increase the amount of funding which goes to funding long-term monitoring systems? Because if you apply for a grant, you have a very hard time applying for something which is already old and is working, proving of concept. So what are the ideas of increasing funding in this line?
Let's take 2 or 3 questions, so it'll give you more time. Please.
Yep. I'm Dr. Christian Widerogo. I'm a risk manager. And my question is about how, despite all the engineering capacities we can have, how can we implement what should be done to overcome the reason for concern if one of the major contributors of the greenhouse emission is not in the deal? What kind of leverage can you have to make sure that we all play the same game? I think you're understanding what I mean. One of the major contributor of the greenhouse emissions is out of the Paris Agreement now. And with all the technology, all the engineering we can have, myself owner of a patent, how can we ensure transfer technology? How can we make sure that the owners of the patents there can accept that some countries where even if they are not emitting much greenhouse, they are facing several impacts. So what kind of leverage do you have?
Okay, thank you. So you're asking essentially, how can we make progress without the participation of the federal government of the US? That's basically your question. So please.
Hi, my name's Rihanna. I'm an environmental historian from Uppsala University. And my question, we keep hearing this figure 1.5 degrees warming in the opening ceremony. They referred to 1.5 degree warming. In light of the 2 years since the Paris agreements and the results that we've seen even today, do you think 1.5 degrees is still realistic? And should we be talking about, even more heating, global warming, basically?
Okay, thank you for those 3 interesting questions, all of them, in fact. So let's start with the first question, and Stephen will answer.
It's a very interesting question, and it's one I recognize very well because I worked in the UK for a long time with the Natural Environment Research Council. One of the questions we always had there was, for a research grant application, was monitoring science? And the answer was ambivalent. If you wanted to put from the research community a long-term research network, a long-term environmental monitoring network, it was not regarded very well by peer review because it wasn't delivering new breakthroughs in science. Nevertheless, everyone understands that one has to have long-term data sets in order to understand what the long-term processes are saying. So I think the problem there is that one needs to divorce the implementation of long-term observations away from the research base. They're not research activities. They are fundamentally monitoring activities that need to be part of the national infrastructure and not judged by peer review in the same way that blue sky research is. So it's a way of structuring the national, or usually national, funding for such activities that I think one needs to address for that. The other questions are,
okay,
1.5.
Second question has to do with how the world responds to the last events that happened. I don't know if Elena would like to say something about that.
US? I think that science event, and here it's very clear, US scientists are very heavily participate in our science everywhere. One of the key centers which helps us to assess global temperature and other data sets in the US. So in terms of science, we are not losing anything. And other question is not relating to scientific event, to my view. And by the way, it's not withdrawn yet. The process is more complicated than when you think. They're still in, and delegation is here. So, and they, what Secretary General Taalas said this morning in the opening, we were actually very pleased to see release of the US own report on climate science, which is extremely consistent with the global science. There is no any discrepancy here at all in terms of science. And I would like to also comment on 1.5, and of course I think that it's IPCC to answer better on 1.5, how we can, are we getting there for 1.5? You know that 1.5 notion was to raise ambition in Paris. The agreement was set to say 2 degrees is our target, but there were so many countries who wanted to raise ambition of others to do a little faster and a little further and more. And so 1.5, to me, it was kind of aspirational target. That is why IPCC was asked to see how feasible it is and what we need to do. But what we can say today, UN Environment GAP report, just released 2 days ago, says the pledges which we have right now in national German contributions is only 1/3 of what's needed to get to 2. So the Paris Agreement is voluntary. Everyone puts the pledges, how much you can do. And this starts becoming, I would like to see a healthy competition to put more and to do further. China is very serious about doing more, and many other countries too. But I think it's feasible, but we shouldn't run ahead of the train and wait IPCC report. That's why they're doing this work.
I would like to comment about the 1.5 target as well. In case it's like for us that we use information, what we need to understand is the potential scenarios. And besides or beyond like having temperatures increases, so what will be in terms of precipitation, I would like to know much better the impacts and how to translate this information into impacts at local level. And then when you go to the government, for instance, they ask you, at least it happens to me, it's like, okay, I mean, it's like by 2050, this is far away. I need something that is for the next 5 years. So this is an additional challenge already. So it's to understand a little bit what does it mean, the different specific warming levels in terms of impacts to design the solutions. But then you also have to face the time slides. You know, it's like for programming, for planning, and so on. So what we like to know is I'm not questioning if it is valid or not, the 1.5. I want to see the different scenarios. What does it mean in terms of impacts for my planning purposes and design better my programs?
Thank you. Maybe something to do would be to fly less helicopters in the sky, but that's another issue.
Yeah. First, I would like to go back to the question about education. All the TSUs, or technical support units, or the working groups, have hired heads of communication. So in this cycle, we put much more emphasis on communicating the knowledge out to the users. And we also have a special effort on climate change and education. So I really support your view that education is really important to make things happen. And then regarding 1.5, the authors are writing the report now, so it's impossible for me to respond to that question. But the Paris invitation is a kind of reflection of the lack of knowledge about 1.5, because the fifth assessment report did not address the 1.5 very much. It was mainly focused on 2 degrees, and that's why we got the invitation from the Paris meeting. And there are several scientific papers being produced now, so in a year we will know much more about what is needed for achieving 1.5. So look forward to the report next fall, please.
If I could just comment on the question about our largest emitter. It's important, as Elena said, to understand that quite clearly the National Climate Assessment, which came out of the US last week, from the science community, is completely at odds with the statements from the administration. That's maybe not surprising. What perhaps is more surprising is that the statements coming from the commercial and industrial sector in the US is also completely at odds with the statements coming from the administration. There are 3 times as many people employed in the renewable energy industry in the US as there are in the coal industry. So if the US really wants to support its own industry, it would do much better to look towards the emerging industries rather than historic ones. Maybe they're the ones that have more influence on the current administration. I don't know. You make them think that. I wouldn't say so. But there are strong opinions. The 7 of the largest states, including California in the US, have already set up independent programs to support the heritage of the research which was being done. For example, I know in California, the national research institutions which are funded federally, which are located in California, the governor of California has sworn that all these will be funded by the Californian government if they're not supported federally. So there is a strong support for continuing research in climate across the United States, not necessarily in every state, but in many of those where most of the facilities occur. So let's hope that we will maintain a true partnership with the US as well, which will transfer over into the next administration.
We're now going to take probably the last round of questions. So if you would like to make a comment, it's probably a good time now. Anybody would like to add a point or ask a question or make a comment?
Yes, good afternoon. My name is Romero. I'm the Swiss focal point for the IPCC. May some colleagues on the podium comment a little bit about the new socioeconomic scenarios, because that IPCC is dealing with, because it's a new matter, and it has to do also with costs related to the various ambitious targets at 2 degrees, 1.5, etc. And maybe we should start some pedagogy for these new share socioeconomic scenarios, which is something that is coming new after we have had the emissions pathway scenarios, the scenarios from the 5th assessment report. So some pedagogy on the costs and consequences and how we are going to transition to deep low emissions pathways. Thank you.
Thank you. This will be a question for Jan in a minute, but are there any other questions or comments at this point? So, please.
Isabella Ploch from the Polish Geological Survey. Therefore, my point of view is a little different because we look much deeper into the past and into much stronger changes of climate. And therefore, I would like to ask about the some geological record from the past of some really similar changes of climate, not from the deep past. I think about the Ice Age, when the climate change came from the really very cold climate into the climate which was warmer than even now. And such record exists and could be very suitable for estimation of possible changes in the future, and the way in which we could adapt. For example, the area when it was real climate change, there was lack of water, which we have such record, and based on this, maybe it could be much easier to estimate future changes and areas which are in real risk. That was my question. Thank you.
Thank you. Is there a last question that I could take before we ask the panel to react? I don't see anybody. I think so. We will ask, first of all, perhaps Jan to respond to the first question.
Yeah, the SSPs represent a novel thing in the AR6, a new, more ambitious set of scenarios. It's a kind of matrix where you have different worlds in the horizontal and different forcing levels in the vertical. And they see different ways to combine forcing levels and different developments. And we have 5 main different worlds developing. And we have the emission scenarios available for the special report on 1.5 and the land report. but these emission scenarios will be fed into global climate models, the huge models, and they will not be ready, I believe, in time for the special reports, so they will mainly be addressed in the big report. So I think that's all I can say now, and they also added a lower scenario to make it more relevant for the ambition from Paris. But you can look forward to a brand new set of interesting scenarios, and we will need to put some efforts into communicating what these scenarios are telling us. So we are very aware of this challenge, of the richness of the results, and we will put some efforts into that. Thank you.
Would anybody want to respond to the second question on paleoclimate and the use of paleoclimate data? Maybe Stefan, yeah.
Just
just
a comment perhaps on that, which is that the difficulty in dealing with paleoclimate is that it's the interaction of climate and humanity which is the problem. It's not climate which is the problem. We don't need to save the Earth. The Earth has done very nicely for the last 4.5 billion years without us, and will continue for another 4 billion years with or without us. It's whether we want to see humanity still continuing to flourish on the planet or not is the question. And since we've been around for a very short period, it's difficult to know what the interaction between humanity might be in such large-scale climate changes. So yes, there have been large paleological changes in climate, but we weren't there to witness them, or more to the point, we weren't there to suffer the consequences. So it's difficult to know really how we can bring together both the physical climate, which we see from paleology as well, with the social aspects which we see today. And this is really the question that José was touched on as well. But even though the science of climate change is extremely complicated, when you bring in the socio-economic aspects and the social aspects, it becomes much, much more complicated. And those are the questions we're going to have to address in order to really seal our fate for adaptation.
Elena?
Yeah, and that's also the rate which we are seeing the change is racing with incredible speed. So you know that our release of the greenhouse gas bulletin actually went back to 50 million years ago. It's the first time we tried to make the comparison of the CO2 now with CO2 then, and it's now shows very clearly that the last time we had a similar level of CO2 in the atmosphere was 2 to 5 million years ago. It was the mid-Paleocene. There was probably different conditions of life on the Earth at this time, but natural changes between the ice ages from and to ice age was always fluctuated between 180 and 260-ish, 80-ish ppms. Right now we are 403 ppm, so this is unprecedented. Also the speed we are adding CO2 in the atmosphere, and now I'm just quoting our own report, last 70 years we have nearly 100 times larger speed of the increase than at the end of the last ice age. So what we are actually doing different right now, we are stretching the change in such a small time frame and also in such a scale. I don't think there was any time in the Earth history an equivalent of something we're having now. It's very, very hard to, and I'm not sure that I can tell you exactly what was the population on 18,000 years ago.
Okay, thank you very much. I think we're coming close to time to conclude. First of all, I'd like to thank all the speakers. I would like to thank also all of you for reacting. I'd like to make a few comments maybe to conclude. Number one, clearly, and since we're talking here about science and research, we should recognize, I think, that the work done by the scientific community over the last years and decade has been crucial in trying to recognize the problem that we are facing, and also has been the kind of the basics for international agreement like the Paris Agreement to be concluded. So science has played a major role, and what I've heard around the table here from the scientists who are here is really a sense of optimism. Not only has the science concluded or brought the information needed to conclude those international agreements, but clearly the community as a whole, broader than the scientific community, has made progress so that the problem is now internationally recognized and that there is a need to take action, and some of these actions have already been identified. So first of all, it seems that the science needs to go on. There's still a lot of aspects that need to be addressed, and paleoclimate was an example, even though we're entering probably in an era that has been completely unexplored in the past. But the science still needs to play a big role. But the science has to be broadened, and we heard it at the beginning of the debate. It's not only a matter for climate scientists, but it's also a matter for engineers, for practitioners, in a way who needs to come up with the definition of solution that policymaker and government can implement. We also heard the importance of education. Education needs to go beyond, let's say, the physics at the university or the chemistry for air pollution. It has to go into broader sectors of humanities and social and physical sciences. So we have new challenges. Many of them are technologically, but again, I heard a lot of optimistic comments here that altogether we can address the problem. It's just a matter of political will. And we hope, of course, all of us, scientific community in particular, that the information that we brought has been useful and will be useful for the fate of the world. So thank you very much, and have a good week and a good afternoon today. Bye-bye.